Hello children, in this video I am going to explain you about the Ohm's law. Okay, I will also discuss the concept of resistance and factor affecting resistance. Okay, what is conductance? Okay, and connections of resistors in series and parallel, series connections as well as parallel connections. Okay, so in the coming 10 minutes I am going to cover all these topics. Right? First one is Ohm's law, children. Very important, Ohm's law. Okay, was a scientist actually. What he told, current passing through the conductor is directly proportional to the potential difference applied across its end. Okay, this is a conductor. So when you connect it to the battery, okay, so current will start flowing through this. He told if your battery is of more power, more current will be there. That is a simple words. So what he told, current passing through the conductor is directly proportional to the potential difference, or we can write V directly proportional to I at constant temperature. What is the condition, children? Temperature should be constant at constant temperature. V directly proportional to I. Once you remove the proportionality, you have to put a constant, that is R into I. R is called as resistance. What it is called as resistance. V is equal to IR. This is the expression of Ohm's law. Ohm's law. Okay, where R is what? Resistance. What is I? I is the current. And what is a V? Potential difference. Potential difference. Am I clear? We can plot a graph also and we can show. Let's say, children, potential difference. SI note of potential difference is what? Volt. Okay, and a current. Suppose if I am applying a potential difference of 10 volt. Okay, current is in ampere. SI note of current is what? Ampere. Let's say current is 2 ampere. If we make it 15 volt, it becomes 4 ampere. 20 volt, 6 ampere. So we can plot this in a graph. This is a potential difference V versus current I, current. I am taking potential difference along the x-axis, current along the y-axis. So potential difference 5, 10, 15, 20 like that. Current 2 ampere, 4 ampere, 6 ampere, 8 ampere. When the potential difference is 10 volt, what is the current? 2. For 10 volt, what is the current? 2. Okay, for 10 volt, current is 2 ampere. For 15 volt, what is the current? 4 ampere. For 15 volt, what is the current? 4 ampere. So you go here. For 20 volt, what is the current? 6 ampere. For 20 volt, what is the current? 6 ampere. So graph will go a straight line. How it will go? Straight line. This is the graph. See, there is a limitation of Ohm's law, children. Ohm's law is not applicable when temperature is too high or too low. First thing. It is also not applicable for non-ohmic devices like a semiconductor diode. It is not applicable. This law is not applicable. Okay, you should just know for your information. Okay, children. Next, we talk about resistance and factor affecting it. Resistance and factor affecting it. See, as we learned that V is equal to IR in Ohm's law, right? What is R? R is called as resistance of the conductor. Okay, resistance is the opposition offered to the flow of charges. What is resistance? Opposition offered to the flow of charges. Okay, so SI unit is what? Ohm. What is SI unit? Ohm. We are writing ohm like this. Ohm. Okay. See, children, there are some factors which affect resistances. Okay, factor affecting resistances. Affecting resistances. First one is what? Length of wire. Length of wire. Okay. See, children, resistance of the wire is directly proportional to the length. It means if length is more, resistance is also more. Understood? Second factor is what? Length. Like this you can see, this is a wire of length L1, another wire of length L2, same wire, okay, made of copper only. resistance R1 is there, R2 is there. If length L2 is more than L1 means what? Resistance R2 will be more than R1. Are you getting? Next factor is what? Area of cross section. Area of cross section. Area of cross section like this. This is called as area of cross section. Okay. So resistance of the wire is inversely proportional to area of cross section. Suppose we have a wire, copper wire of area of cross section of small a1. Another copper wire which is having more area of cross section a2. Okay. This is thick wire, thin wire we can say. Resistance is R1, resistance is R2. Here inversely proportional means what, children? If area is more, area of cross section is more, resistance is less. As A1 is less than A2, this area, okay, of this wire is less than this. So resistance R1 will be more than R2. Am I clear? Correct? Even it depends upon temperature, children. Resistance is directly proportional to the temperature. If temperature increases, resistance also increases. Are you getting my point? And one more factor is there, nature of material. Nature of material. For conductor, it has less resistance. Conductor has less resistance, whereas insulator has more resistance. Insulator has more resistance. Am I clear? So you should know all these concepts. Now coming to, okay, what we learned so far, that resistance is directly proportional to the L, inversely proportional to area of cross section. Once you combine this, children, what we can write? R directly proportional to L by A, right? When you remove the proportionality, you have to put a constant. This is rho, okay, rho L by A. Rho is called as what? Resistivity. What is called as resistivity of the conductor. Okay, this is a very important. They may ask you problems based on this. Resistivity are also called as a specific resistance. What it is called as? A specific resistance. Am I clear? Now see, children, as R is equal to what? Rho into L by A. If you cross multiply, what we can write? R into A is equal to what? Rho into L. So or we can write R into A by L. This is in multiplication. When it moves to left hand side, division, that is equal to rho. So rho is nothing but RA by L. This is the formula to find out the resistivity. As the resistance, what we learnt, rho is equal to what? RA by L. Resistance is in ohm, area is in meter square, length is in meter, meter and square get cancelled. So what is SI unit of rho? SI unit of resistivity is nothing but ohm into meter. What is this? Ohm into meter. Am I clear? Okay. You should know, children, conductance. What is conductance? Conductance is represented as generally Z. It is nothing but reciprocal of resistance. Conductance is nothing but 1 by resistance. Am I clear? Okay. So what is SI unit of resistance? Ohm. So it is what? 1 by ohm means what? Ohm inverse we can say. SI unit of conductance is what? Ohm inverse. Next we talk about, children, conductivity. We talk about conductivity. Conductivity is generally represented as sigma. Okay. It is nothing but reciprocal of resistivity. Reciprocal of resistivity. Okay. So sigma is what? 1 by rho. As SI unit of rho, what we learnt? Ohm meter, right? So ohm inverse 1 by ohm into 1 by meter means ohm inverse, meter inverse is the SI unit of conductivity, or we can say Siemens per meter. Siemens per meter. Am I clear? Okay, so these are the important concepts where they may ask you numerical space on this. Coming to the resistors in series. Try to understand, children. Suppose there is a one resistors R1, other resistors R2, other resistors R3. If one end of this is connected to one end of this, one end of this is connected to one end of this, and they are connected to a V volt battery. Okay. In this case, what is the R equivalent, children? RS is nothing but R1 plus R2 plus R3. Okay. You want to R equivalent of the circuit in series, they just get added up. Okay. If you want to know what happens here, children, here this battery is there, it will give a current I. Same current passes through R1, R2 and R3. So what you can say, I is same, children. What is same? Current is same. Okay, here when I current passes through R1, there is a potential difference across this which is developed V1. Okay, by Ohm's law what we can say, V1 is equal to I into R1, right? When I current passes through R2, there is a V2 is developed here, I into R2. Similarly, when I current passes through R3, here V3 is developed. Okay, so what is V2? I into R2. What is V3? I into R3. Here what happens, children? This voltage is divided among the three resistance. Okay, so V is equal to what? V1 plus V2 plus V3. Important concepts you should remember. Here voltage division takes place in series. And if you want to know the total current is nothing but voltage by R equivalent, means RS. Based on this, you can solve the numericals. Next, we talk about the resistors in parallel. Suppose, children, there is a one resistance R1, other resistance R2, next resistance R3. If one end of this is connected to one common end, let's say A is there, one end is connected to A, other end is connected to other common end, let's say this is B, and that is connected to the V volt. Okay, so such connections are called as parallel connections. Here see, here again I current will pass through this battery, as three different resistances are there, and the paths are also different. So here the current passing is what? I1, here I2, here I3. Here, children, current division takes place. What happens? Current division takes place. So here what we can say, I, total current is equal to what? I1 plus I2 plus I3. I is equal to I1 plus I2 plus I3. And here voltage is same, children. What is same? Voltage is same. Because one end of this is connected to A, other end is connected to B. Similarly, one end of this battery is connected to A, other end is B. Here voltage is same. What is same? Voltage is same, or we can say potential difference is same. Okay, or potential difference is same. Means here whenever I current passes through R1, so here V1 is developed, right? V1 is equal to what? I1 R1. Okay, yes or no? Similarly, I2 into R2 will give you V2, right? Na? I3 into R3 will give you what? V3. Here I1 into R1 will give you what? V1. But here what happens? V1 is equal to V2 is equal to V3 is equal to V. Okay. Now if you want to know what is I1, children, I1 is equal to what? V1 by R1 by Ohm's law, because V is equal to IR, right? So I1 is, and I is equal to what? V by R. What is I1? V1 by R1. This voltage by R1 will give you I1. Now what is V1? V. So V by R1 we can write. What is I2, children? V2 by R2. As V2 is nothing but V. So V by R2 we can say. Similarly, what is I3? V3 by R3. So is what? V by R3. Now what is the formula for getting the equivalent resistance? Here 1 by Rp is equal to what? 1 by R1 plus 1 by R2 plus 1 by R3. This is the formula to get the equivalent resistance in parallel. Okay, you have to take the reciprocal of resistance. 1 by reciprocal of resistances in parallel is equal to sum of reciprocals of individual resistances. Okay, if you want to know the total current is nothing but voltage by Rp. Okay, the next class we will solve the problems based on the resistors in series and parallel. If you like my video, please share with your friends, okay, and subscribe the channel. Thank you.